3.5 Guided Practice. The objective is to solve problems using segments and angles. Some of the beginning of this I think will be a review for you. So let's just start. Given R is between G and H, we need to come up with a statement and we need to come up with a reason. So I'm going to go ahead and follow the hint and sketch a figure whenever possible. So let's see. R is between G and H, so let me draw a line segment with G and H, and let me put R in between. And I think we're going to use the segment addition postulate to say that GR plus RH equals GH. This is that the measure of GR plus the measure of RH is equal to the measure of GH. And that, as I said, is the segment addition postulate. Going over to number 2, we're given that T is the midpoint of line segment WS. So let's go ahead and let us draw a picture. So we've got a line segment WS with points W and S, and T is the midpoint. So we know that those smaller line segments are congruent. So we can say that the measure of WT equals the measure of TS, and that's because of the definition of midpoint. Good. Let's go down to number 3, and I'm going to switch to black pen. I think it shows up a little bit better on the video. Given that line segment WS bisects angle AWD. So let's draw line segment AWD. Let's draw angle AWD rather. Okay, so this is angle AWD, and line segment WS, which I'll draw like so, bisects angle AWD, so therefore it creates two smaller angles, each of which are congruent with each other. So I think our statement would be that the measure of angle AWS is equal to the measure of the angle SWD. And the reason is the definition of angle bisector. All right, good. And let's go on to number 4. G is in the interior of angle MNP. So let's draw angle MNP. MNP, that's the angle MNP. And let's place G in the interior. Not necessarily symmetrically in the interior. It could be closer to one line than the other. And what would our statement here be? Well, the sum of these two smaller angles is equal to the larger angle. Remember, this is not necessarily an angle bisector. That's a mistake I've seen people make sometimes. The fact that G is in the interior does not make NG automatically an angle bisector. But we can say that the measure of angle MNG plus the measure of angle GNP equals the measure of angle MNP. So the sum of the smaller angles adds up to the measure of the larger angle. And that is because of the angle addition postulate.